Hello. I hope the course is going well for you. I hope you are keeping to the schedule, doing the lessons, homework, assignments, tests and everything going on time. Remember, if you fall behind, it will be very difficult to make up. If you have any concerns or questions, always contact me. It is very important that you keep in touch with me so that you understand and learn the course properly. Alright? I want all of you to learn, appreciate and enjoy this course. It's very important that you enjoy a course in order that it may be useful to you. Okay, in today's lesson we will discuss another new concept called momentum. What does the word momentum means? It is a word that we very often use. Now I have a trolley here. Does this trolley has any momentum? Well, at the moment it doesn't have a momentum. But if I set it in motion, it has a momentum. Now, what does the momentum of a moving object depend on? What are the factors on which the momentum of a moving object depend on? Well, there are two factors. One is the mass of the object, and the second thing is the velocity. It is the combination of these which gives a moving object its momentum. Now tell me, is momentum a vector quantity or a scalar quantity? Well, momentum is a vector quantity. While the trolley is moving forward, if its momentum is positive, when it is coming back, its momentum is negative. Alright, let's put this in. So, a moving object has a momentum determined by its mass and velocity. And how do you measure momentum? Momentum is measured as the product of its mass and velocity. We will represent momentum by the uppercase P, and if you measure momentum as the product of mass and velocity, what will be its unit? Mass is measured in kilogram, velocity is measured in meter per second, therefore momentum will be measured in kilogram meter per second. So P equal to m times v kilogram meter per second. And we talked about this. Momentum is a vector quantity. That means when you want to add momenta of different objects, we use the rules for vector addition. Okay, let's consider a car of mass m moving with a velocity v0. What is the momentum of this car? Its mass is m, its velocity is v0, therefore its momentum is m times v0. Let's now apply a force F on this car so that its velocity changes from v0 to vf. Alright, this force F will change the velocity from v0 to vf. And the time taken for that change is delta t. Tell me, what is the new momentum of this car? The new momentum will be its mass times its new velocity. What is the acceleration produced on the car? Acceleration is delta v divided by delta t. Delta v is vf minus v0. And this change in velocity occurred during this change in time delta t. Therefore, the acceleration of the car is vf minus v0 divided by delta t. But you know that f equal to ma. So, if I now replace this a by this quantity, Vf minus V0 over delta t, I can now write F, the force applied on this car, is mass times Vf minus V0 divided by delta T. Now take a moment and look at the numerator quantity and tell me, what does that represent? If I now multiply by m, or distribute that m, it will be m times Vf. What does m times Vf represent? The momentum at this time, or we call it the final momentum. Is that right? M times Vf is the final momentum. What is m times V0? Initial momentum. So this is mVf minus mV0, final momentum minus the initial momentum. The quantity on the numerator actually represents the change in momentum. M times Vf minus V0 represents the change in momentum of the car. So I can replace that numerator m times Vf minus V0 by the quantity delta P. So I have the force acting on the car equal to delta P divided by delta T. What does delta P divided by delta T represent? The rate of change of momentum. So force is a measure of the rate of change of momentum of a moving object. Look at this. We have a new way to measure force. In fact, the definition of force in Newton's Principia is given in terms of the change in momentum. The force acting on an object is a measure of its rate of change of momentum. An important definition. Force is the rate of change of momentum. Let's now obtain a relation connecting kinetic energy and momentum. Tell me, what is the equation for kinetic energy of an object moving with a velocity v? Kinetic energy is 1/2 mv squared. The kinetic energy K of a moving object can be expressed in terms of its momentum, and sometimes it will be very useful to do that in solving problems. Alright, kinetic energy of an object of mass m moving with a velocity v is K equal to 1/2 mv squared. Now, what I have done here is multiply and divide by m. Is that difficult to do? Now, watch here, 1/2 mv squared. I multiply and also divide by m. Now, why did I do that? Well, to make it a little more user-friendly. Look at this. If you don't want it, these mass and mass get cancelled. But by multiplying the numerator by m, this becomes m times mv squared, become m squared v squared, and the denominator is now 2m. If you don't want it, 1m can be cancelled with another m. We will go back to our original expression, K equal to 1/2 mv squared. But I'm sure you now understand 1/2 mv squared is the same as m squared v squared divided by 2m. What is the advantage of writing like this? Well, m times v is momentum p. Therefore, m squared v squared is the square of the momentum. The numerator is p squared. So, kinetic energy equal to p squared over 2m, where p is the momentum of the moving object. A very important relation. I want you to keep track of that. Okay, let's do a small problem. A 0.5 kilogram ball is thrown in the x direction with a velocity 10 meter per second. It hits the wall and rebounds with the same speed. Well, same speed. If you want to talk in terms of velocity, the velocity of rebound has the same magnitude but opposite in direction. The question is, what is the change in momentum of the ball? Alright, our data is mass of the ball is 0.5 kilogram. Its initial velocity is 10 meter per second. That means the ball comes and hit the wall with this velocity. And after hitting the wall, it rebounds with a velocity exactly opposite, equal and opposite. Vf equal to negative 10 meter per second I. Vi, initial velocity is 10 meter per second I. Vf, the final velocity, is negative 10 meter per second I. Alright, now the initial momentum of the ball is Pi equal to mvi. Is that right? Mass times initial velocity. That will be, mass is 0.5 kilogram. Initial velocity is 10 meter per second I. I hope you now understand this. In the x direction. And that is 5 kilogram meter per second I. The initial momentum is 5 kilogram meter per second in the positive x direction. Alright, this is the wall, and look what happened. The ball came, hit the wall and went back. So the initial momentum is 5 kilogram meter per second in the positive x direction. What is the final momentum? The final momentum Pf is mvf, mass times the final velocity. The final velocity is negative 10 meter per second I, and that is negative 5 kilogram meter per second. This is the final momentum. Now tell me, what is the change in momentum? The initial momentum is 5 kilogram meter per second I. The final momentum is negative 5 kilogram meter per second I. What is the change in momentum? What is the definition of change in momentum? Final momentum minus the initial momentum. That is the definition of change in momentum. So change in momentum delta P is Pf minus Pi. I know at least some of you thought in your mind that the change in momentum is zero. Is the change in momentum zero? No. The final momentum is negative 5 kilogram meter per second I, and the initial momentum is 5 kilogram meter per second I. Look at this, final momentum minus the initial momentum, and that gives you negative 10 kilogram meter per second I is the change in momentum. The change in momentum is in the negative x direction, and it is equal to negative 10 kilogram meter per second I. Very important to understand that concept. Okay. Now this represents, so the red arrow represents the initial momentum, the green arrow represents the final momentum, and the blue arrow represents delta P, the change in momentum. Alright? Okay, let's try another.